Welcome back to this second chapter on performance. I'll be picking up where we left off. We'll see that the default for single-valued relationships is an eager fetch. And we'll see that that has caused a performance problem for us on this course already. It happened in an earlier chapter, but I ignored it there. It's time now to look at it in detail. It's going to be something called the n+1 selects problem. This is usually a really bad situation to be in. I'll give you a few strategies for handling the problem. There's no one best way. You need to choose the best depending on the situation. One advanced strategy is called batch fetching. It's a bit hard. I'll explain here what it is and what it isn't. And I'll finish by reminding you that Hibernate offers various alternative tools. When you hit performance problems, it's often because there was a better strategy to use. We'll have a good talk about that. Time now for a warning. We've seen that collections are by default lazily loaded. And we've seen the kind of impact that that might have on your code. However, something I've always found quite confusing is that single-valued relationships, if you've used the annotations for the mapping, are going to be eagerly loaded by default. If you're using the XML mapping that we saw a long time ago now on the course, the opposite's true. Single-value relationships would be lazily loaded, but I'm assuming that you're working with annotations. We need to be clear that if you're to load a student object, because each student is associated to a single tutor, then that relationship will be eagerly fetched. Now, you might not think that's a big deal, but I can tell you that it can cause some quite strange performance problems. Well, in fact, this problem occurred earlier on in the course, and I deliberately ignored it. Let's return to the problem. The scenario that we're going to explore probably couldn't get any simpler than this. All I want to do is load all of the students via a regular query, and then I want to output the name of each of the students. I'm not interested in tutors. I only want to access the student data. By the way, there is a better way of doing this. You can start thinking about what that better way is. We met it earlier on in the course. But for now, I'm going to say that this looks like a perfectly normal way of outputting the names of all the students. Let's go try it. Now, because this is a simple example, I'm not going to bother using the architecture that we've been working with the tutor management. Let's go back to our simple performance testing test harness. Just before I run that, I'm going to go back to persistence.xml and return my HBM to DDL back to create, because with this performance test harness, we can automatically set up the data at the start of every run. I'm going to remove now my earlier test, and I'm going to replace it with the one we've just seen. So I want to load in all the students first of all. So we'll get a list of students. We'll call it all students. This is going to be a query, which is going to be select student from student as student, and then we can just call get result list. A very easy query, although I need to use the proper class name there, and just get the imports in place, java.util.list and student, and then I can iterate around the results. Now, of course, I'm only printing out the name of the student as an example. I could, of course, do anything I like with the students. That's compiling. Let's check that it runs. It certainly looks okay, but I think a really important point has to be explored here, that it's really not enough when you're writing JPQL queries to just assume that, hey, they work okay, let's not worry about it. I would recommend that you always check the generated SQL when you've written a query for the first time, even one as simple as this. Because if we do look at the generated SQL here, we've got something really worrying. Let's go up. This is the last of the inserts. So here is our select, where we're selecting the student data. But really worryingly, it turns out we have a second select and a third select. We've seen 3 different selects just to achieve that very simple requirement. Why 3 selects? Well, that's so complex, I'm going to have to explain it using a caption. So let's have a look at what's happened here. Well, when we did our original select, we're selecting all of the students. So Hibernate has dutifully done a select, which has loaded in the students. So we now have 1 select executed. But because the default is for Hibernate to eagerly fetch single-valued relationships, Hibernate is then going to check all of the students that it's loaded. It first of all considers student number 1, and it knows that student 1 is related to the tutor of ID 1. So it does a second select to load that tutor into memory and to relate that student to that tutor. So we've now gone up to 2 selects. Hibernate then looks at student 2. Well, student 2 happens to be related to the same tutor. And Hibernate knows that it's already selected that tutor. So it doesn't issue a select this time. It knows it can just immediately relate that student to the tutor it loaded earlier. This is an aspect of caching, and it's something we'll be looking at in a later chapter. But then it gets to student 3, and for student 3, well, this is related to tutor 3. We haven't loaded that tutor so far, so Hibernate will issue a third select to load this tutor into memory. So we've seen here 3 separate selects. It was 1 select for the student collection, and then a further select for each of the tutors that appears in the graph. Notice in this case we didn't need a select for tutor 2 because they're just not appearing in this object graph. But this is really bad. Remember, we didn't even need the tutor information in our use case. We only wanted the students' names. And yet we ended up with 3 select statements. And you can imagine this is a very simple situation. In a real application, that could be a performance killer. This problem, generally speaking, is called the n+1 selects problem. And this is such a problem, I think we need to be a bit more dramatic with our slide. This really can be a performance killer. So n+1 selects is a general problem where we see 1 select for the parent object and then a further select for each of the child objects. Now please don't be too hard on Hibernate when you see this problem. Again, it's something that Hibernate can't kind of cleverly work out is happening for you. You need to be aware that you're walking into the n+1 selects trap. Although I will admit that in this case, I think it's a really bad default that Hibernate is eagerly loading the tutors. So much so that I would recommend, as a general rule, when you're working with a single valued relationship, you switch the default off and you switch to lazy loading. Let's see how we can do that. If we go into the student class this time, and we find the relationship to the tutor, and here it is. The relationship is defined via the many-to-one annotation. If here you set fetch to be fetch type dot lazy, you've now overridden that default. And from now on, whenever we load a student, we will get a proxy for the tutor. And only when we access that tutor will the tutor be loaded into memory. Now that will be good in our case, because now Hibernate will load all the students with a single select and won't bother with the further selects. If I give this a run now, we've got the 3 students as required, but if we look at the SQL log, that's great. There is now just a single select appearing. Don't forget that if we did want to do an eager fetch, we could do so, and we would just use the syntax that we saw earlier when we did a left join fetch in the HQL. So just to review that, I want you to remember that when you're working with annotations, single valued relationships are eager by default. So if you load a student, you will also get the tutor loaded, whether you wanted it or not. And we saw also that because of the way Hibernate implements this, you might end up with the n+1 selects problem. So my recommendation is that you switch single valued relationships to lazy, and that will maintain consistency with collections, and you can always do an eager fetch as and when you need it. Something that is really important to remember is that you can't avoid performance problems, in particular the dreaded n+1 selects problem, just by mindlessly switching on a few annotations and assuming the problems have all gone away. So we previously saw that the n+1 selects problem that we had in this code here, where we're looping around all of the students and outputting their names, we could avoid n+1 selects problem by switching lazy initialization on for the relationship to the supervisor. But the n+1 selects problem can always come back again, depending on what I'm doing. And the point I'm trying to make is that you really should always be checking the generated SQL to make sure that you're not accidentally causing performance problems. Let's go back to this code from earlier. We now know that this performs quite well. We get just a single select statement to select all of the students. But if I add just one extra requirement, you'll see that we get straight back to the n+1 selects problem. Let's say that for each of the students, I think I've done this kind of thing before, I want to output their supervisor. So I can call getSupervisor. In fact, I can call getSupervisorName, but I think I'll do it the long-winded way. GetSupervisor followed by getName. It doesn't matter if you do it the other way as well. Now, it was really easy to enter that code, but I hope you can now see the problem. Every time we call this getSupervisor method, Hibernate is going to have to perform a select to initialize the proxy. Let's run the code and check the log. And yes, we have one select there for the student, another select for the first tutor, and another select for the second tutor. A classic n+1 select scenario. Now, I've said this kind of thing before. Please don't blame Hibernate. It's really just another mismatch between relational and objects. Using Hibernate, I think, makes the problem just look worse, because it was so easy to add this call to the getSupervisor. We forgot that that was going to result in a database trip. If we had been using straightforward SQL to achieve this requirement, we would have probably given the situation more thought, and we would have been less likely to hit this performance problem. So, What can we do to solve the n+1 selects problem this time? Well, first of all, one obvious solution that you might think of, and it doesn't work, would be to go into the student and to change this lazy back to an eager, which is actually the default on single valued relationship anyway. First of all, it's not a good idea because, as I mentioned, I think it's best to have lazy as the default, but it doesn't work because the way Hibernate interprets that is that as soon as it's loaded the student's data, it should then immediately go and eagerly issue a separate select for each of the tutors, which is just the n+1 selects problem again. Far better to leave it switched to lazy. Now the answer is to simply perform an eager fetch at the point that we do the query. And we do that, as you know by now, by specifying left join fetch. And in this case, we want to eagerly fetch the student's supervisor, and that will make sure that the fetching of the tutor happens in the same select statement as the retrieval of the students. Let's run that through, and we'll check the SQL, and this time we have a single select statement with a left outer join, and that's the only select that's been issued. So the left join fetch here, which resulted in a left outer join in the SQL, worked, and it worked well. And I think in this scenario, it was probably the right choice for the problem. However, if there had been, let's make some numbers up, let's say 10,000 students, each with a tutor, the left outer join would have resulted in a really big database query. And the database might not have been able to deal with a query of that size, particularly if the relationship had been a one-to-many relationship. So in that case, we'd be kind of stuck. If we used the lazy loading and removed the left join fetch, we would end up with 10,001 individual select statements. And the database would be able to handle all of those small selects, but it would take a long time to process them all. Or we could have one giant select statement with a left outer join, which is potentially going to return too much data all at once. There is a middle ground we can employ. Now, I've got to warn you that this is advanced Hibernate. In fact, it's probably the most advanced topic I'm going to cover on the entire course. It took me a long time to get to grips with it, so I'm just telling you that so I don't scare you off. If you don't understand it the first time, you're not alone. I was the same, and you can always come back to it another time. But please stay with the video, because once I've covered this concept, there is a little bit more to come, and I wouldn't want you to miss that. So this advanced concept is called batch fetching, and it's designed for exactly the case I've just described, where we don't want 10,001 tiny selects, but we don't want one giant select. I want something in the middle. Now what I can do here on the tutor class is I can specify an annotation at the class level. The annotation is called batch size, and it takes a single parameter. The parameter is called size, and I'm going to start with a batch size of 10. I'll explain what this does in a moment, but before then, when I import the annotation, notice, I'll just need to drop down my annotation list. Notice that this annotation is unusual in that it's not from Java Persistence. It is from the Hibernate package. That's because this concept is only supported as a Hibernate feature. So if you do use this in your code, you would only be able to run your code on Hibernate. So let's have a look at the effect of setting this batch size annotation. We're going to do our query as before, where we select all of the students in the database. Now we have 10,000 of them in the database, so we will get 10,000 objects in memory as a result of a single select statement. Now, because we're using a lazy relationship from the student to the tutor, we're going to have these uninitialized proxies for the tutors. And I'm representing the proxies here with the red crosses. When we try to access the first student's tutor, as you know by now, Hibernate will automatically load in that tutor's information. And I'm representing the tutor object there with the green oval. However, the big difference is, if we have a look at the select statement that Hibernate will have used to initialize that tutor, it's going to look something like this. It's doing a select from tutor, but not where the ID is equal to 1, but you can see it's including 10 IDs in the where clause. Those IDs, by the way, are the IDs of the tutors. Now, Hibernate knows the IDs of the tutors because they are the foreign key references in the student table. So actually what Hibernate has done, even though we've only accessed the first tutor so far, is Hibernate's gone ahead and with a single select statement, it's initialized the first 10 of those proxies. Now, technically, by the way, it can actually pick any of the proxies to initialize, but you'll find that it works through them by order of ID. So we're looping through these students. Now, we only wanted at first the details of the first student's tutor, but now you can see that behind the scenes, Hibernate has loaded 10 tutors with a single select statement. So now, as we continue through the first 10 students, we will see no further SQL. But when we hit the 11th student, this is another uninitialized proxy. So Hibernate will now go ahead and initialize another 10 tutors. Now, I ran out of space for tutors there, but this time it will have initialized tutors 11 through to 20. So by the time we get to the end of this collection of students, instead of 10,001 select statements, we're going to end up with, well, I think it's going to be 1,001 select statements. Well, that's still a lot. So we might look at increasing the batch size, maybe to 100. Now, sadly, this is a kind of a very hard-coded property. You can't vary it at runtime. So setting this batch size is a bit of a broad brush optimization, but still it can prove very useful at breaking down very large queries. But does it work? Let's go back to the code. So remember, I've set this batch size to be equal to 10. And actually what I've done off camera is I've modified my performance test harness to include a much larger range of tutors. In fact, I've now got 14 tutors in my system, and I've also got 14 students. I've kept things simple in that most of the tutors are just looking after a single student, but I think our original tutor 1 is still looking after 2 students. If you want to use this setup data method, you'll find this method in the sample solutions folder for this chapter. So you can easily get hold of this from the practicals and code folder. Anyway, let's go back to our query. So we're doing a regular select with no eager fetching. And actually, before I run this, I'll just comment out the batch size so we can see what happens without the batch size in place. Let's run the test harness, and I think we're expecting here an n+1 select problem. If I maximize the console, yes, let's go all the way to the top of the selects. There's our first select where it's selecting all of the students, but then we're getting a select for the first tutor. That tutor's looking after 2 students. There's our select for the next tutor. There's our select for the third tutor, and it goes on. I think you're going to find 14 or 15 selects appearing there. Clearly not a good thing. But if I reinstate this batch size and run the code again, and we now check the console again, it's going to look very different. There's our original select, which is loading in all of the students. And then we have our select, which is loading in the first 10 tutor proxies. And you can see the question marks here. There will be 10 of them. And that's meaning that the next 10 accesses of tutors is hitting an already initialized proxy. And then we get to the next batch. Well, Hibernate knows there's only 3 more uninitialized proxies. So there are the final 3. So we've now reduced the, I think it was something like 14 or 15 selects down to just 3. Now don't forget that the batch fetching is just an option. I could have alternatively used, as we've done before, a left join fetch on the student supervisor, which would mean that the whole graph of objects is loaded up with one single select and a left outer join. As I mentioned, that might return too much data in one single select, in which case you might prefer to use the alternative, which is a lazy fetch, but with a batch size. Now, it is a bit of an advanced concept. It can take some serious tuning to make it work, but I thought I'd better mention it. In fact, one of the reasons that I've covered batch fetching is because there's quite a common misconception with batch fetching. I want to be clear that batch fetching is only used to load groups of uninitialized proxies, just as we've seen. It cannot be used to load parts of collections. To explain this, I'll just need to look at the relationship in the other direction. In other words, imagine you've just loaded in a tutor object. Any of them will do. Now we know that each tutor has a collection of students that they look after. But because of this lazy initialization, at first, Hibernate won't load the students. It will instead have a proxy for those students. I'm representing that with the small circle here. Then, when we access the first of those students, even though there might be 10,000 students in this tutor's collection, they will all be loaded immediately using a single select statement. There is no feature in Hibernate that will allow you to somehow load just some of those students. It's very easy to mix this concept up with the concept that we've just seen before. But the concept we saw before was where we had lots of uninitialized proxies. In this case, there's only one uninitialized proxy, but it's representing a large collection of objects. Well, it's nearly over now, and I hope you're not too depressed about performance topics in Hibernate. As I've mentioned many times before, I think it's really only because Hibernate can do very clever and powerful queries that it's often easy to lose sight of what is happening under the hood. In my opinion, as a Hibernate developer, it is essential to have a good grip of the underlying SQL. And you need to be able to strike a balance between object-oriented cleverness and performance querying. Let me go back to the main example that I've been working on throughout this chapter. I wanted a list of all of the students, just their names, together with the name of their supervisor. Now we saw that the code was quite easy and it looks very nice and object-oriented. I'm calling regular methods. It feels very Java-like. But we've worked quite hard through this chapter looking at all of the performance problems that we might have with that code. In particular, we saw that we were hit by the n+1 selects problem, which is always something of a nightmare. Well, we got around it and we understood that there are various techniques and various strategies for making this work. I'd say the main one is a left join fetch on this particular query because we know we're going to need the tutor information as well. But don't forget that the students and tutors returned by this query are also now objects, and those objects are being stored in memory. Well, in this case, the memory is being released when we reach the em.close, but nonetheless, there might be a problem there in that we might be using up too much memory on the computer that we're running on. Now, I hope that you've spotted that there was all along a much better way of doing this query. Now, you might not have spotted it because the clues were much earlier in the course. The answer is, instead of using this type of query, I could have used a reports query. Remember from earlier in the course, a report query is where instead of creating objects that we're going to call methods on, we do a more SQL style query where we select specific properties from an object. In this case, I want to select the student's name followed by the student's supervisor's name from the student class. It's not quite SQL, but it's much more like SQL than the kind of queries that we've been doing most of the time. The main weakness of this type of query is we don't get proper objects back. Remember, what we're going to get back are pairs of strings in this case. So I can't do any fancy object-oriented work. I can't call any methods on the students or the tutors. I can output each student name and each supervisor name, which is all I wanted for this requirement. In this solution, we're going to see a single select statement and none of this lazy initialization, and certainly not an n+1 select problem. Have a think about that while we try it in the code. So I will comment out the code here. I'll comment this as an alternative, a report query. I think I'll do it as one line of code, slightly different to the slide. This is going to return a list of object arrays. I'll just call it results. And this is going to be em.createQuery. This time I'm selecting, instead of the whole object, I just want the student's name and the student's supervisor's name from the student table or the student class, whichever you prefer, as students. It's as easy as that. And then we call getResultList as usual. So as I mentioned, the weakness of this is it returns a rather unpleasant list of object arrays. And each element in that array is just a simple string. So if we output the 0 element, that will be the student's name, is supervised by, and the 1 element is going to be the supervisor name. And all being well, unless I have a syntax error in here, the output looks good, but crucially, a very simple select statement. Now, I'm not saying that this approach is better than the approach that we were using before, but it's a different tool, and especially if I'm not planning on calling any methods on these objects, this can often be a much more elegant way of getting the data we need. To use a real-life example, one of my first jobs when I joined Virtual Pair Programmers was that I had to write a sales page for our system administrators so that we can track how well our courses are selling. It's not a very pretty page because it's only used by our internal staff, but we use it to list our sales, which courses are selling well, and we have a report here which shows us where in the world our courses are selling, and so on. Of course, I've blurred out all of the sensitive data from this report, but I can do quite a lot here. I can search by specific dates, and I can look for all the orders from a specific person, and so on. Now, when I first wrote this functionality, we were a new company. We hadn't got many sales, and I needed to get the code working with the minimum of programming. So I used HQL to retrieve all the objects representing our sales, and then working with those sales objects in memory, I was able to write some really natural Java to get the information I needed. I probably did something like I called the getCountry method from every one of my sales objects and did a little bit of Java to add the figures up. So I was working very much with Java methods, and as a Java programmer, I felt really comfortable with that. There wasn't an SQL join in sight. But just a year later, the performance of this page was starting to get really worrying. And that's because effectively, with that single HQL query, I was loading all of the database into memory, because every sale is linked to the customer making the purchase, which itself is linked to the courses that they've bought, and quite a lot of other relationships as well. So I was getting literally thousands of objects into memory. And this was really starting to strain our servers. So every time our company's boss loaded this page up, the entire website slowed down. So then it was time for a rewrite. And this time around, I used a combination of report queries, but also don't forget, we can also use regular SQL. So for example, to calculate our total sales for Europe, I was no longer creating thousands of objects in memory. I was merely executing a single select statement. And if there's one thing, only one thing I really want to hammer home on this course, is that Hibernate is not intended to replace the database. It's intended to simplify access to the database when you're wanting to work in regular object orientation. The perfect scenario for Hibernate is where I want to load a single object, or maybe a small collection of objects via a HQL statement. I then want to call some methods on the objects that I have, and those methods may or may not change the state of the objects in memory. And when I reach the end of my unit of work, I can let Hibernate work out whether or not the data has changed and let it deal with the dirty check to synchronize the database. On the other hand, Hibernate is not good at jobs such as complex queries, especially reports, or for bulk operations. And that's not a criticism of Hibernate. That's because Hibernate doesn't really intend to do those kinds of jobs. A good example that we met earlier in the course was that we wanted to double the salary of every tutor in the college. Now you could do that by using HQL to load all of the tutors into memory, then loop around the tutors and call the set salary method for each one, and then let Hibernate do a dirty check. Now that might be okay if you have a small number of tutors, but it is going to mean loading all of the tutors into memory, which means lots of objects. And there's also a potentially expensive dirty check, and you will see a separate update statement for every single tutor. Doesn't sound very good for performance. And we saw in the querying chapter that Hibernate allows you to do bulk updates and deletes. So we did an update statement via the Entity Manager's create query method, and it looks something like this. And that resulted in a single SQL update statement. Much better performance. Now for me, most of the performance problems that companies experience with Hibernate is often down to them assuming that for some reason all database operations have to be performed by doing an exotic HQL query, calling Java methods, and then using the dirty check. But I want you to know now that you always have the option of using report queries, bulk operations such as these updates and deletes, and you can always, if you want to, go back to regular SQL. It really is a case of just choosing the best tool for the job, and you're always going to mix and match the tools. Anyway, I've probably spoken for too long now, but to summarize, when you are using Hibernate queries and using dirty checking, be careful to look out in the log for any n+1 selects or overly complex joining, especially if you're working with deep object graphs. Well, we're not really finished with performance just yet, because the next two chapters are dealing with caching, which itself is related to performance. Watch out for this n+1 select problem. It's funny in that it can catch you unawares, and I proved that. Earlier in the course I did a simple select on students and actually ended up with n+1 selects. One for the students, but then one extra select for every single tutor, even when I didn't need them. So we saw a few strategies. Probably a left join fetch would be good in most cases, but there is also batch fetching. That's a bit advanced. I've not seen it used that often, but when done right, it can be a useful tool. For me, the most important part of this was the ending discussion, which is that Hibernate gives us lots of tools and you need to choose the most appropriate for the job. You've got report queries, bulk updates and deletes, and there's always regular SQL. I'll see you for the next chapter. We've got 2 chapters on caching, and the first of them is crucial to your understanding of Hibernate, so don't miss it.